Good morning, students. Welcome to the physics class. Today we are going to study about the nature of the physical laws. So what is the meaning thereby a physical laws? Okay. The physical phenomenon occurs in a nature are well explained on the basis of the what here the certain laws. You already know that the physics is we are studying this particular physics under the macroscopic and also what is that the microscopic ideas. So, the macroscopic means we are studying about the galaxies, a very big the space, and also the microscopic in the sense we are studying the lesser than what an atom. So, these phenomena, in all physical phenomena we are studying about the what here the macroscopic and also what is that microscopic concepts. So, the several things in physics, or you can say the several quantities in physics, or remains the constant in a nature. So, that particular constants are termed as an what here the conserved quantities. These conserved quantities like charge, energy, momentum, so these are all conserved quantities in physics. So, these conserved quantities are studied under the several laws. So, that is what we are considered as a what here the law of conservation of charge, law of conservation of what energy, law of conservation of linear momentum, law of conservation of angular momentum, and also the mass and energy. So, these are all we are going to study in a nature of what here the physical laws. So, you already know that the law of conservation of charge, what is the meaning thereby? The total charge in an isolated system is always what here that remains constant. This is what we termed as an what here the law of conservation of energy, charge. The charge in an isolated system, you are come to know that what is the meaning of this isolated system later. For time being, the total charge in an isolated system remains what here the constant. So, this is what we termed as a law of conservation of what the charges. And you already know that law of conservation of energy, energy is neither be created nor be destroyed. The sum and the total energy which is remains what constant in nature. That is why we are saying it can be interconvertible, that is all. If energy is there, that means that potential energy is there, we can convert into the what here the kinetic energy, and that kinetic energy to the mechanical energy, chemical energy, light energy, heat energy, we can able to convert those energies. But the total energy of the system is always what here conserved. So, this is what we termed as an what is the law of conservation of what energy. And we have another law is called as conservation of linear momentum. You might have studied in the 9th standard. The total momentum before the collision is equal to the total momentum what is that after the collision. It means that in an isolated system, the total momentum of an isolated system that remains what here the constant. So, this is what we termed as an what is the law of conservation of what linear momentum in the physics. So, you already know that the rotation of Earth, the revolution of Earth and all other planets, and the electrons which is revolving around the what here the nucleus of an atom. So, these are all comes under the what here the law of conservation of angular momentum. The total angular momentum of the system about that particular axis remains of what the constant we are studying. So, this is what the law of conservation of what Angular momentum, it is nothing but the same as a what here, the linear momentum, conservation of that linear momentum, and also what is that, we have an angular momentum. And the lastly we have the law of conservation of mass and energy. So energy is converted into the mass is converted into the what here, energy. Mass and energy in nature are interconvertible quantities. So you know the well known equation, that is E is equal to mc square, is an Einstein's mass relation, where the C is, this particular C is considered as what here, 3 into 10 to the power of 8, it is nothing but a what here, the speed of light in a water, the vacuum. So these are all the considered as what here, so nature of physical laws of conservation of charge, energy, linear momentum, angular momentum, and also what is that, mass, and also what is that, energy relationship. So these are the nature of what is that, physical laws. So thank you for watching the videos. Thank you very much.